building out a fiber network, scalability, build for the future, not as a snapshot in time. You want to make sure as you bring on more subscribers, you have enough bandwidth to go around. From a reliability, really, this could be pretty much up to the network operator's decision, as well as how deep are your pockets. From a reliability standpoint, if you build multiple fiber rings and ring technology, really the sky's the limit for yourself. You just have to make that decision yourself as it relates to how comfortable you are with the level of a reliability that you want to deploy. Availability kind of falls within that same realm. Typically, most operators try to stick within a 4 nines network, meaning 99.99% uptime. Typically, that's measured over a period of time. Survivability also falls in that. Really also plays into reliability and how diverse you set up your network infrastructure. Security is another big one, obviously, with cyber threats and bad actors within the network and computer environment today. Just some thoughts around simplifying your network. As you build out the network for, I'm specifically speaking as it relates to XGS-PON or GPON networks, which are typically deployed in fiber to the home. As you configure your network, really layer 2 is typically built out from the XGS and GPON world. As you get higher up into the network, then you start transitioning into layer 3 from a network backbone. Within that layer 2 environment, really, you definitely want to avoid deploying a flat network, such as a network that you haven't segmented through VLANs, separating your traffic. For example, if you deploy voice, video, and data, obviously to separate those service instances, you want to use VLAN deployment. And then there's a couple of different VLAN provisioning models. There's a N-to-1, which is a one to many environment as you send a VLAN out on the network. And then there's also a 1-to-1. So you could actually use one VLAN for every instance of service that you're trying to turn up. If you're deploying the N-to-1 VLAN environment, there's some security items that you definitely want to probably adhere to, which would to lock down MAC force forwarding and also to turn on IP source verify. What this will do is make sure that any bad actors that are trying to connect onto your network can't gain access to the network, because the MAC force forwarding makes sure that no bad MAC addresses or unknown MAC addresses can actually hijack or take over your network. As we're walking through XGS-PON deployment, XGS-PON 10 gig symmetrical passive optical network. The passive part is actually because you use passive splitters to distribute the network, taking multiple service instances over a single fiber. How that's accomplished is kind of a timing. It's a timing of the technology on how each of the optical network nodes are able to communicate. They take turns. But as you start to think about this with your communities, there's a couple different splitter models that you can deploy. There's what's called a centralized splitter model, where it's one to many. And then we also have other providers that maybe it's what's called a distributed split. So instead of going from one cabinet and just splitting to every house, you might want to push out to a different community. So you'll have the cabinet, a 1x4 splitter, which allows you to get out to that other community, and then say a 1x32 to a much larger community. It's just called a distributed split pattern. Probably one of the key, most important items in starting a network. Obviously, identify your site requirements, statement of work, network diagrams. You want to map everything out, make sure that you have everything detailed so it can go into your engineering database, because if you win the lottery and take off and you're the network operations director, you just took the knowledge out the window, right? And plus you want to make sure that everything's detailed and written out so that everybody else knows how to operate the network if you win the lottery or what have you. Configuration details. This also helps for overnight. You have folks that are on call. You're not always going to be there 24/7. So this is also a database where folks that are on the night shift can go in and troubleshoot the network. So this next slide kind of depicts the importance of the network design as it relates to the network itself. It can often help network folks determine and isolate areas of where the network may fail, and it gives them a visual depiction of the network so they know where the issues might be. Number 5 kind of actually falls within the first slide that I opened up in address capacity bottlenecks proactively before they impact subscribers. So that really boils down to, again, as you sit down to design a network, know the number of subscribers, try to guess your potential take rate, and make sure you forecast for future bandwidth and possible subscribers that you're looking to bring in, or even as you bring in new areas of the network. When you, oftentimes when you first build out the fiber to the home network, there are a couple of different ways that you can build it out within the system as it relates to the subscriber or the end user. Some broadband service providers track it by the address, some track it by the device ID. There's no right, wrong, or indifferent way to do so, but definitely make sure that that's the way you're going to commit to, because if you need to make a change later on down the road, it could be problematic because you're going to have to re-provision every one of your subscribers. Oftentimes, as we change technologies, for example, if we're going from GPON to XGS-PON, this is where the drawings and the diagrams and the network information needs to be up to date, right? Because we're going to go ahead and migrate those existing subscribers over to the new technology. Really making sure your database and records are up to date is imperative here. Go for it.
I got a question. So what is XGS and all this kind of stuff? What is GPON? Why do I want it in my network?
Sure. GPON is gigabit passive optical networking. It is an asymmetrical service that gives you about 2.5 down, 1.2 gig up. XGS-PON is X equals 10, gigabit internet Ethernet, passive optical network. It's 10 gig symmetrical. It allows you to deliver multi-gig services.
Very cool. Cool. So 10 gigs to my house could be realized, right? So what can I put on there? You know, most of the laptops only have 1 gigabyte NIC cards. I mean, what else could I put on there to make this all work together good? So what do you got?
Absolutely. As I realized when I started with Calix about a year and 2 months ago, too much. I have the Ring doorbell. I have the Ring security systems. I'm happy to say I don't have my refrigerator online, but I do have my thermostats. Pretty much every device nowadays, right, comes smart, and you can get on the network and take a look at that. While that does chew up bandwidth, to your point, 10 gigs is a lot of bandwidth. And honestly, full transparency, when folks do look at the bandwidth and how much they're using, sometimes it technically feels like, you know, I've got 10 gig to my house and I'm just going to talk about it. But in reality, they're probably not leveraging the full capacity, obviously, of 10 gig. But it allows you to put more devices, stream, game, and manage network devices.
So if that breaks, my router's got kind of screwed up, or maybe somebody next door stole my password for the router. I've got like some 200 devices on there or 150. Is there capacity where you could just get in there and fix that for me?
Well, my grandparents and my parents seem to think I can do that all the time. But really, it'd be up to resetting the router itself or kind of figuring out how to get back in the router. So,
all right. So one more question. So what kind of network do I need to put this on to get that last mile? So this is kind of like from the pole to the house. That's 10 gig of service that connects to some box somewhere. And then network that's providing that kind of service for those boxes. What kind of network is that?
Again, GPON was a starting point a few years back. We're seeing a lot of our broadband service providers migrate to the XGS PON for multi-gig capability. North of the pole to the house, there's typically collector rings, and that's really up to kind of what I opened the presentation with, is from a network design perspective, aggregating all that traffic, right? So we see providers with 100 gig links, rings, all the way up to 400 gig link rings. It's really about network capacity and planning.
Okay, great. So if I have this ring and it gets cut, it's going to stay working, right?
If you built it accordingly and had ring switching, it would, yes.
Great. So we built some redundancy into a lot of these networks. These are some of the standards that we're looking at. And how many people can I put on one card? It's kind of like, I know it's a party brand type of broadband network. Back in the old days, we had party lines. So we had 2 or 3 people, somebody be listening to your call or something else. And you had to have one or some kind of weird rings for each person. But now GPON is kind of along those lines, right? It's kind of like a party line. You're sharing it with other people. So tell us just a little bit about that.
Sure, you've got it. Early on, I talked about passive optical network splitters. That's what's called a split ratio. And to your point, on, say, any of our cards or any of our the folks that also deliver XGS and GPON, really it depends on the network engineer and how they design it. But you can go all the way up to, on XGS, you can go all the way up to 1 by 128 way splitter. So you could effectively put 128 customers on one port.
Okay. So would you really want to do that? So if that one port goes out, all 128 port guys go out? Since you try to, well, that's up to your engineer, right? Let's just say they want half of that on one card. That effectively would kind of alleviate that kind of a problem, right?
You got it. You got it. It's really up to the network manager and engineering department on how much pain. Because while we'd like to say that all of our cards and machines last forever and don't go down, stuff happens, right? So it really is up to the appetite of whoever's designing the network.
Cool. Hey, that's great information. And XGS, that's what you guys should be striving for. In the field, hopefully a lot of new networks are built that way. GPON is kind of the preferred method. There used to be another one called Active. Is that still around? Does Calix have that?
We do. Active Ethernet is still around. Not to mince words, but as I talked about, that one-to-one relationship from a VLAN perspective, Active Ethernet is good. In the long run, it's going to cost you a lot more money because you're going to basically chew up one port per customer. Whereas that's the advantage of the passive optical network, is you're able to do that party line, as you say, and share the fiber link. But there are use cases, maybe, for Active Ethernet. We have seen some broadband service providers leverage Active Ethernet for maybe their business clients that don't have the appetite for passive optical networking. Thank you.
Thank you so much. And, Active is also pretty fiber intensive, so you got to run a lot of fiber.
That you do.
So great. Thank you, guys.
Thank you.